Bom dia, pessoal. Os alunos vão entrando. Bem-vindos aí a mais uma palestra da nossa série da Introdução à Engenharia de Som. E hoje, antes de eu apresentar o nosso palestrante, eu queria dar só duas informações. Primeiro que para os alunos matriculados, eu passei para vocês nos seus e-mails, nos alunos matriculados no curso pela Unicamp, né? Eu passei para vocês, por seus e-mails, uma lista de presença. Eu peço que vocês verifiquem se está tudo em ordem lá e caso vocês não receberam qualquer coisa, entrem em contato comigo depois da apresentação, tá? Só para a gente controlar essa questão da presença. A outra coisa é que eu queria comentar com vocês que um colega nosso, o professor Regis Faria, da USP, está com um projeto sobre avaliação de áudio espacial no contexto da TV digital, né? E ele está procurando alguns bolsistas. Então, se alguém tiver interesse de trabalhar, de fazer estágio nessa área de avaliação de qualidade de áudio espacial, também manda um e-mail para a gente, que aí que eu posso mandar mais informações para vocês, tá bom? Bom, dadas essas informações iniciais, vamos então falar do nosso palestrante de hoje, que é o Martín Rocamora, professor da Universidade Nacional do Uruguai, que fica na Universidade da República do Uruguai, né, que fica em Montevidéu. Ele vai então contar para a gente um pouco do trabalho que ele faz na área de processamento de sinais musicais extraído de gravações sonoras. Martin, thank you very much for accepting our invitation, and we are very interested to know what you've been doing and to see what you have to share with us. Our virtual floor is yours.
Ok, obrigado, Bruno. Eu queria pedir desculpa que eu não falo muito bem português, então a palestra vai ser em inglês. Mas se tem algum problema, é só falar. Alguma dúvida, é só falar. And so, thank you very much for the invitation. You're having a great seminar here. As far as I can see that there are very nice, you had very nice talks. So I hope you enjoyed this one too. It's going to be about the work we've been doing here in the last few years in a small group we have here, a research group we have here at Universidad de la República in Montevideo, Uruguay. We not only work with music, but most of the work we do is related to music. So that's what we are going to talk about today. So Bruno asked me to start by saying how I ended up working in this field. So this is a picture of the School of Engineering in Montevideo City. So I entered the School of Engineering with the idea to somehow find a mixture between two of my most important interests that were engineering on one side and music on the other side. Actually, my father is a programmer. He develops software and also he's a drummer. So I have some kind of legacy from him. And I as I said, I entered the School of Engineering with the idea of focusing on the relationship between engineering and music. So I try to do different projects in the courses, and even my graduation project was related to music. Then I had a great opportunity to start working as a teaching assistant in the School of Engineering and at the same time in the School of Music. So I entered the School of Music and I had a nice relationship with other kind of people, composers, musicians in general, and also musicologists. And this experience has changed completely my way of thinking of music and the way I listen to music. And it was a very enriching experience. After working for more than 10 years in the School of Music, I finally got a full position in the School of Engineering. And then I moved only to the School of Engineering, but I still work and do research with people from the School of Music. We are actually 3 professors in the School of Engineering, 1 more professor in the School of Music, and of course, students and other collaborators involved. We even have students from Brazil in the past. So let's dream with with a better future, in which a not so distant future, in which we can perhaps receive some of you here in Montevideo to do an internship and some research on the things we're going to talk today. Okay, so is it fine? Are you listening okay? Yes, no problem?
Yes, it's working great.
Okay, thanks. Okay, so going...
Martin, you're mute now.
All right, I think it was... Okay, let's go.
Okay.
Thanks. Going directly to the research field, we work in a research field that can be called music information retrieval. It's known by this expression, meaning that you extract information, relevant information, musically relevant information from different sources, like lyrics, audio recordings, pictures, videos. And most of the systems that are developed in MIR actually are related or rely on audio signal. And that's our case also. And so the idea is to start from low-level descriptors, extract from the audio signal, like the waveform or the times frequency representation, or things that you can compute from this low-level representations, and try to scale up to high-level musical concepts, like, for instance, to find the notes that were played, or even more, let's say, advanced things like trying to classify to which musical genre this music belongs to. And to do that, you actually use signal processing a lot in order to process the audio signal, and also machine learning in order to convey, in order to derivate those high-level concepts, right? So that's where I actually work. I mean, I teach and do research related to signal processing and machine learning applied to audio signals, particular audio with musical content, right? And so, in particular, we are very much concerned with expressive music performance. I mean, among all the things you can do related to music, we are actually very interested in expressive music performance. I mean, when a performer shapes various of the parameters related to music, like tempo, timing, dynamics, intonation, or articulation, in a way that is not actually prescribed by the notated score, or even when there's no score, perhaps it's not actually present in the conceptual idea you have about the music. For instance, You may have a rhythmic pattern, and you think of it as for instance, 4 equally distributed notes in time. But when you actually go and see and analyze how these notes are played, perhaps they are not played in this way. They are not played equally distributed in time, right? And this kind of information is actually very, very relevant in music, right? As a kind of joke, I would say that it discriminates or allows you to differentiate from accomplished performers like the one above and an amateur like the one below, right? So we focused on different dimensions of music, expressive music performances, but in particular, in the last few years, we focus on rhythm. We work trying to discover patterns and structure in rhythm, and also micro-timing, which I'm going to talk a little bit in a few minutes, which is small-scale temporal deviations in time of the events of the music, right? Fine. So something I always try to think of our research in this way. Our approach tries to bring as much musical knowledge as possible to the methods. We work in a kind of circle, like the one represented below. We go to the sources, either musical sources or perhaps the relationship with performers, the people that are involved in this kind of in the music we are studying, and then we try to formulate musically relevant analysis problems informed by those people and those information sources, and then we try to convert those problems into engineering formulations, right? And so we end up with some results, and this usually conveys other questions, and you end up working in a kind of circle that's quite interesting and enriching, as you not always know where you're going to end up, right? Fine. So let's move now to one of the most important music styles we've been working with in the last few years. If you happen to come to Montevideo, you will probably find people playing drums in the streets. This is part of a long-standing tradition that was originally developed by African descents in Montevideo City, but nowadays has been adopted by the society at large, but it still remains as an identity symbol for communities of African descent people, right? So I'm going to show you a brief video of how this happens. Not sure about the audio quality, but I guess you can identify the different drums there. You have different sizes and different pitches. And these drums are related to, each type of drum is related to a different kind of rhythmic pattern, right? And you also have this pattern in which you play with the stick in the shell of the drum. That's called madera. Okay, so if you listen to the small drum, which is called the chico, if you listen to it alone, you have a pattern like this that's represented here graphically to the right, and it's called the timekeeper. It keeps the time and defines the subdivision, the smallest subdivision. But if you listen to it alone, the location of the beat meaning where you would clap or where you would tap your feet to, it's somehow ambiguous, right? You'll probably select this point here, the first stroke, which is a hand stroke, as the beat, right? Pakataka, 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 pakata. And this is actually wrong, right? In fact, if you listen to the clave pattern, you realize that, well, the beat is actually placed in the silence of this pattern, of this Chico pattern. And the interaction with the clave defines the location, not only the location of the beat, but also the rhythm cycle, right? It's you have 4 beats, which are divided into 16 pulses, right? So here you have a pattern, and you could count like this. 1, 2, 3, 4. 1, 2, 3, 4. Right? Then you have 2 other drums, the repique, which is essentially improvised. So here you have the clave pattern and the repique. And as I say, this is essentially improvised, but you have a characteristic primary pattern that is used frequently in a performance, right? Like that is described here in the score, and it sounds like ga 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 ga, right? And then finally you have the piano, which is the lowest one, the lowest sounding one. In essence, it's aligned with the clave, but no one would play like this, pa, 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 pa. This is a kind of the skeleton of the pattern, but you actually play different rhythmic patterns associated with this drum, right? It's important to say that the kind of pattern, the way you play the piano, is an important stylistic marker, right? That defines different styles, different neighborhoods, and also the style of different performers, right? And so we may listen to it all together with the other drums. Okay, so this adds this audio example adds the lowest drum, right? Okay, so this gives a rough idea of the rhythm. And so what we did with this, first of all, we had to build data sets for rhythm analysis. We did a lot of recordings, either in the streets and also in the studio and in theaters like this one here. And we released some data sets for doing research, either audio-visual, meaning that we also have video, or only audio with annotations. That's very important. If you don't have annotations, you cannot use the data sets for research. Annotations like the location of onsets, where the events happen, and also the location of beats and downbeats, meaning the location of where you tap with your feet to the music. and also the location of the beginning of the rhythm cycle. I think in Portuguese is like cabeça de compasso, the beginning of the rhythm cycle, right? So we address different problems related to this kind of music. The first one is the automatic detection of the beat and the downbeat. This music is quite challenging for doing that, because as I mentioned before, remember that the location of the beat is actually in the silence of one of the rhythmic patterns, and this is somehow contrametric, or it's somehow not very intuitive, right? But most of the things we did was the analysis and the discovery of rhythmic patterns. Let me show you an example of that, how we do that. For this, I'm going to use we have a library, a Python library called Karat for computer-aided rhythm analysis toolbox. We are actually upgrading the library, so you may have a look at it. We have some examples. I'm going briefly through one of these examples. We start to show how we extract rhythmic patterns from the audio signal, right? And so we load the audio and also the beat annotations that were extracted before with the other techniques I told you. So you have an example like this. So you have 3 drums playing there. We're going to focus on the lowest sounding one, the piano, the biggest one. And so we load the annotations for the beats and the downbeats, right? And we compute from the audio signal an accentuation feature, meaning that this signal here in green is going to have higher values when the musicians actually play the note in this place, right? And it also has other information, like if the stroke was stressed or baffled, and things like that. And then what we do is we consider each rhythm cycle and represent this rhythm cycle using scales of gray as a column in this sort of map below. Are you looking at the examples, right? Yes, okay. So we represent this feature map in this kind of, we represent this feature signal in this kind of map. In the vertical axis, you have the beats, 1, 2, 3, 4, right? This is a complete rhythm cycle. And then in the horizontal axis, you have the different rhythmic cycles, right? So time goes up and also from left to right, okay? So imagine you are going, you play only the first beat, like 1, 4, 1, 2, 3, 4. So you're going to have a black line here at the bottom, right? This is the representation. And so if you look at the map, you see that there's a lot of variations in the patterns, but there's also a lot of structure there, right? You have patterns that are quite similar one to each other, and also there are differences. So what you can do is you can cluster those patterns automatically using machine learning, and you get sort of proto-transcription of this performance, right? This is a complete performance, and this rhythmic pattern corresponds to the patterns that the piano drum, the lowest one, played, right? And so you can analyze the performance itself. You can see, for example, that whenever you have a sky blue or cyan pattern, then you have a pink one, meaning that there's a relationship in time. One pattern follows the other. This is because one of the first one works as an anacrusis of the second one, right? And then well, you can see the centroids of those clusters. You can represent those clusters in a lower dimension in order to visualize how they're grouped together and do some sort of analysis. And for instance, you may listen to the recording, one pattern alone. You may focus on the lowest sounding drum, and you see that the patterns play are quite different, right? It's like tuk tumba tuk tukumba, this one. And for instance, this one is completely different. Right? So that's the way you get the patterns. And okay. So what do we do with these patterns? Well, you can do several things. For instance, you can represent those patterns. The example I have shown now, it's only one performance, but we can analyze several performances with different performers, different styles, and you can compare the patterns that are played by different performers, right? So in this representation to the left, you have a 2D representation of different patterns. Those patterns are grouped by performer, meaning that they actually play different kind of patterns. And well, and there are different kind of analysis you can do with this sort of approach, right? They reveal family traditions and neighborhood styles and things like that, right? Other thing you can do is represent to the right. Remember the clave pattern, like ka, 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 ka. Well, this is the prototypical pattern of the clave, but actually it's very common that, I mean, you don't play this pattern alone. Actually, you play many variations, many different kinds of clave patterns, right? And so what you can do is you could analyze a complete collection of recordings and automatically identify where you have a clave pattern because of the timbre of the sound. And then you could analyze those patterns and group together the different types of pattern. And well, we did this, and what you obtain is different families of clave patterns and all the variants you have, right? Okay, and other problem we addressed relates to the microrhythmic analysis of these patterns, right? I mean, small-scale temporal deviations with respect to an underlying metrical grid. Imagine you have these points here, right? They represent somehow the metrical grid. Well, would you expect to have an onset, right? And this grid is thought to be isochronous, right? Meaning that all the points are equally spaced in time, right? But you may analyze, as I said before, some of the patterns. For instance, you may concentrate on ostinato patterns of 1 beat of the Chico drum. Is the pattern I mentioned before, like pa pa, okay? And then the repique primary pattern, pow 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 pow. And you can actually measure or analyze where the onsets are actually present, right? And you can see here a representation of the points in time for one performance. Beats increase outwards, right? And so what you can see is that the Chico, instead of being located at 25%, 50%, and 75%, it's actually ahead of a division in 4 that you would expect for this pattern, right? And regarding the repique, you also have a location of the last onset that's actually closer to a ternary division and not to a binary division in the way we usually think of this pattern, right? And well, you can analyze also this is an example of one recording. You can analyze a complete collection of recordings, and you see that those things are actually systematically present in the music. And so if they are systematically present, we may ask, well, so they are part of this kind of music, right? And so it's interesting to listen to it. We did some work with Afro-Brazilian music, and I'm going to show you a simple example. Instead of listening to a chico or a repique that you're not probably used to, I will show a schematic example of a tambourine, right? That actually plays four notes, right? And so this is an animation that shows schematically the results we have with analyzing Afro-Brazilian music. These are equally distributed in time. And this is more close to what we actually measure in a real performance, right? So I don't know what you perceive, but the second example is closer to what you have in mind about the tambourine playing the typical pattern, right? Fine. Okay, so with this information, we address some, let's say, higher level musical questions, right? First of all, we were interested in the interpersonal relation of musicians playing together, right? This is called entrainment, and relates to how musicians synchronize and coordinate their performance when they are playing together, right? In order to study that, we first compute asynchronous between musicians, meaning that, okay, if we play together, let's say with Bruno, we play music together, and so we play a note at the same beat. Okay, we play together, but maybe I played a little bit before, or Bruno a little bit after me. Okay, so these asynchronous are very common in music, and the question is, I mean, are they play by chance? Are they errors, or actually they have a meaning, or they are used to convey some sort of information in some way, right? There's a lot of discussion of these things in the musicological literature. And so we study this sort of things, right? And all this information, when you put together all this information, it allows you to ask, as I say, higher level musical questions. For instance, in this representation, we have at the top, you have the rhythmic patterns represented with the colors, right? So this is a schematic representation. Not all the rhythmic patterns are present there, but okay, you have this information. You also have the tempo curves, meaning that you track the tempo in the recording, and you can see how the tempo evolves in time, right? You also have information about dynamics, right? If the music is played louder, or well, this information could be related to other dimensions of music. You also have the asynchronous between musicians, and so if you put all this information together, you may ask questions like, how musicians negotiate tempo and dynamics? I mean, what's the relationship between the patterns they play, the asynchronous they have when they are playing, and changes like a tempo change, right? So let me show you a small example of that. You are going to see a recording in which they start playing slowly, and suddenly they increase the tempo. So the idea is that somehow they share information between them in order to signal that they were going to increase tempo, right? And I'm not going into much detail here, but the different, the asynchronous, playing ahead or after the other musician, the patterns that you actually play are different ways of conveying this information to the other performer, right? By the way, we use this sort of analysis also in the video in order to extract information of the movements, in particular the movement of the hand, which is somehow related to the dynamics of the performance, right? Fine. So another dimension we were very interested in addressing was, okay, you have those asynchronous, you have those micro timing, but what actually musicians think of them, right? I mean, are they aware of this micro timing, or what do they think? Do they prefer music with micro timing or not? I mean, to address that was something that we were very much interested, right? And so we took part in a study regarding the aesthetics of musical timing. We tried to study the preferences of musicians when they were show systematic deviations from synchrony, meaning that you are not using an isocronous grid, right? Sorry, isochrony. You're using an isochrony or not an isocronous grid, and also synchrony, meaning that the musicians play, as I said, before or after the others, right? And so we consider, with a group of researchers, we consider different music styles, including candombe, as I said, and also djembe music from Mali, Africa. And we departed from the micro timing that we measured in the performances and did manipulations of this micro timing, either regarded to the isochrony of the metrical grid and also regarding the synchrony between musicians, right? And so we did a lot of preference tasks in which musicians listen to the examples and say if they are different or not, if the examples are different, and also which one they prefer, right? And the results showed that the isochrony or non-isochrony is very relevant for musicians. I mean, they are aware of that, and they usually prefer the music that follows, the renditions of the music that follows the original non-isochrony. And regarding synchrony, well, that's not so clear. I mean, synchrony seems not to be so relevant in at least for the results we obtain, right? Fine. So let me show you a couple of more examples. We try to extend this kind of analysis to other sort of musics. For this we have a collaboration with people from Rio de Janeiro, Universidad Federal de Rio de Janeiro. People from the School of Engineering and the School of Music took part in this research. So we did similar things that we did with candombe music. We also created data sets with, in this case, with percussion instruments. I'm going to show you a brief example of that. Okay, so these recordings were done for research purposes and are released as data sets for research, are available for doing research. We also did some compilation of traditional recordings of complete ensembles in Afro-Brazilian samba. And we extended also the methods. We did some work on jointly tracking the beats, as I said before. That was one of the first problems we addressed, but also incorporating the information needed in the system in order to track the micro-timing. Okay, so you track in the recording at the same time the beats, the downbeats, and also the micro-timing, right? And we are still working with this this kind of music, and we are doing addressing other problems like source separation in this context and things like that. Okay, and so finally, we also extended recently this kind of work in collaboration with people from Argentina, from Universidad de La Plata, to Argentinian tango, right? And so we did some analysis of performance style, particularly from historical tango recordings. We addressed the study of the style of Aníbal Troilo. In particular, we focus on expressive timing of performances. We use for that the tempo curves of the performances, and we did correlation of the tempo curves at different temporal scales. And so it's quite interesting what you can see, the differences you can see between different orchestras, tango orchestras, and the way in which styles can be tracked systematically along different instrumentations, right? Different ways of playing. Okay, I don't know if I'm okay with time.
You're good in time. Yeah, so we have another quarter. 15
okay,
minutes.
that's great, because I didn't want to take the whole time with the presentation. Yeah. Just want to end with this picture that I like a lot, because it represents that this music we talk about today, it's alive, and it's still evolving, and that we have a lot of work in the future to do with this sort of music in order to enjoy them, in order to better understand them. So that's for my part. I'm open to questions, and I'd like to share thoughts with you.
Yeah, I'll go ahead and start asking one question. Is how do you determine the onsets?
Right.
Do you measure by, you track the position of the stick, or do you do it acoustically later on?
In general, we do it acoustically later on. For detecting the onsets, the onset detection is a whole problem in signal processing, and it's not a completely solved problem at all, because it depends a lot on the kind of music you're working with. Anyway, if you focus on percussion instruments, this is quite straightforward, or a lot simpler than with other musical instruments, because actually let's say you can differentiate between the physical onset and the perceptual onset, and the difference between the physical onset and the perceptual onset, it's quite small, and you actually have an energy increase in the signal. So by seizing the spectral changes, the energy changes in the spectrum with care and with doing it properly, you usually end up with a decent onset detection with not so much problems. Anyway, there are exceptions.
Yeah, and you do that with
There are
conventional
exceptions.
signal processing, right?
Sorry?
You do that with conventional signal processing, no machine learning processing.
Mostly yes. Mostly yes. Anyway, you may use machine learning with that too. Yes. Yeah. I mean, using machine learning it's a little bit more useful when you have a more challenging situation. But usually, using only signal processing in this context is enough. I should say that we have recordings with separate channels for each drum.
Yeah.
We usually do this kind of analysis in this way. I mean, we are not dealing with all the mixture together for the onset detection. Other kinds of analysis, yes, we use the mixtures.
Great. So Guilherme sent us a question here. Guilherme, do you want to go ahead and make a question? Open the mic, or should I read it out? So let me read it. On the to compute the feature map you presented us, you have 4 bits on the y-axis. Could you change the number of bits according to the change of time signature in a song? Also, how does this analysis deal with polyrhythmic songs or irrational time signatures?
Nice question. Yes, I think the map, we actually adapt this map to other kind of music in which you don't have only 4 bits, but 2 bits. And the other part was polyrhythmic. I mean, different time signatures.
How this analysis deals with polyrhythm songs or irrational time signatures?
I mean, polyrhythmics, it's different from irrational time signatures. Polyrhythmics may refer to you have different sort of rhythms going on, the same kind of music. So you usually have a time base in which both kind of patterns could be analyzed. So I say that depends on the kind of polyrhythm, but usually you could select a time span in which the rhythm cycles are.
Your audio just cropped for us, Martin. Could you repeat your last sentence? We're not listening to you.
Yeah, still. Okay.
Try again.
I am here now.
Yeah, now we're listening.
Oh, okay. So I'm sorry. I was saying that of course polyrhythmic. Of course, both both situations that are are somehow for the representation. But I say polyrhythmic you have to go.
So yeah, your audio is really cropping the way we cannot understand what you're saying. Sorry. Is this maybe your internet connection, do you think? Or maybe if we all turn off our cameras for a while. Free some band. Okay, let's try again.
Okay, do you hear me?
Yeah.
I'm terribly sorry.
No worries.
Okay, so I said that both situations that are raised in the question are challenging for this simple representation I showed. But the polyrhythmic case could be addressed by selecting a time span longer enough to cope with the polyrhythms that are going on in the music. But maybe the case that is complex enough, so the good solution. And the other part of the question was related to we have different time signatures, and of course this is not easily addressed, cannot be easily addressed with this simple representation. Perhaps you should have two parallel or three parallel maps going on.
Okay. Somebody suggesting that there's some feedback on your audio. Maybe that's what's turning the...
Okay, but I'm using
headphones. Yeah, okay.
Perhaps it's not.
We are working. It's working
acoustic feedback, but.
One other question, I think you already answered this, but someone is asking if these parameters you measure, like asynchronicity or, for example, can be determined with only one single track, or do you always need individual recordings?
No, I mean, it's very, very difficult. Have overlapping sounds. You also have the acoustics of the room, sometimes interfering with that. So what we actually did was working with independent, for this particular kind of analysis, tracks for each read. Sometimes we use contact microphones that are more appropriate for kind of natural situation. It's always hard to record a popular music manifestation without interfering it, right? Mm-hmm. But sometimes using contact microphones was a good solution for reducing the amount of bleeding from the sounds of one drum into.
I guess. I get it. Another question that came out is how robust your methods are to reverberation.
I say that I was thinking of what kind of method in particular, but of course, reverberation is an issue. Whenever you have to select an onset in particular, you should deal with that. You have a lot of reverberations. This may add spurious detections, but in the situations we usually deal with, that are recordings that are done in a controlled environment, reverberation has not been a very important problem. But of course, if you want to apply these methods in the wild, meaning that you don't take care of reverberation and try to do this outside of the streets, you probably will fail.
Yeah, I guess one other option would to acquire the signals without crosstalk would be to use accelerometers. Did you think about that?
Yeah. we thought about that, but just in as an option, but we didn't try this. The only thing we tried was contact microphones.
Uh-huh. Good. Any other questions? Will, Eric, do you have anything to add?
Yeah. Go ahead, Julian, please.
Yeah, no, I was wondering to ask, when you are translating from sheet music, which is a strange name, I would say partitura, from partitura to
Yeah.
to the, when you try to translate from partitura or sheet music to the music or the sound, or when you try to go the other way from the sound to the paper, to the sheet music, we know that we have problems to translate when we're dealing with frequency analysis when using Fourier transform, because the resolution is limited and constant. So what's your thoughts on overcoming this idea on translating music?
You mean analyzing the time, as I said at the very beginning, analyzing the like this a time frequency representation?
Yeah, for example, yeah.
Yeah, right. Well, I mean, time frequency representations not necessarily involve a constant grid in the frequency axis. You may consider using other representations like Mel spectrogram or the distribution of the frequency bands that resembles more or less exception. And depending on the problem you address, this could be better. For instance, I didn't talk anything today about, I haven't talked today about other sort of analysis we did regarding pitch. And for doing this pitch analysis, we actually developed a time frequency representation that somehow adapts itself to the music to the kind of signal it's dealing with. In particular, develop a transform that's called fun chirp transform, in the sense that instead of using sinusoidals as the basis for the analysis, you use frequency chirps.
I see.
And so you do this by sampling the audio signal non-uniformly, resampling the audio signal in order that a chirp transforms into a constant frequency sinusoid, and then analyze, do the Fourier transform of this resampled waveform. And so in this particular case, when we're trying to analyze, as you say, you don't have, you may have in a score a certain pitch and then another pitch. In the actual performance, you have a complete continuous pitch contour that sometimes it is the artifact of feature that you want to study for in your particular research. So in those cases, we were particularly interested in tracking precisely the time frequency, the pitch contours that were actually performed in the music. And those pitch contours change a lot, right? So we developed this time frequency representation as you suggested, particularly for doing this kind of analysis. And so, sum up, I would say yes, you would need to develop specific tools in order to shorten the gap between the sort of analysis you do and the actual physical or musical phenomenon you are trying to do with.
Okay, thanks. That's quite interesting. I definitely will look into that. Gracias.
Okay, good.
Okay, I guess we've covered the questions. Eric, do you want to add anything?
I think that's a quick question only. Thanks, Martin, for the presentation. You showed some study where you showed the perception of musicians through all this information. And I'm wondering if you have any thoughts on how this retrieval information can be used in teaching music.
Teaching music?
Yeah.
Well, what I can think of, I don't know if it's related to your question actually, but something that I found very interesting in relation to this study is how music expertise is revealed through this kind of study. I mean, those musicians that play candombe here are really master drummers, in the sense that they can play really tight to each other, really tight to each other, much tighter than any other kinds of music, because they play really fast tempo, and they are able to follow each other and to convey this kind of micro timing in a way that's very precise in time, despite the fact that they are playing really fast, right? So something that I found really interesting about this kind of research is how these musicians are really experts in the kind of music they are dealing with. So all this study was done using two groups of people, right? Each of these music styles, in each of these music styles, we consider 30 musicians and 30 students that were not familiar with the music. I mean, they were, for instance, in Uruguay, they lived in Montevideo City, as well as the musicians, but they were not drummers, I mean, candombe drummers. They were not part of this tradition, right? And so the results that you see, you may say, well, that's obvious, right? But it's nice to see this happening in the research, right? The results and the difference you see between expert drummers and non-drummers, it's quite striking, right? So they are able to differentiate, and they are able to grasp many details about the manipulations we did with the music. This was quite interesting, right? And so, related to your question, you said that if this could be used into teaching music, or I would say that you have to be really humble about the abilities and the experience and the knowledge of popular music practitioners. Sometimes they have a really evolved relations with music that are very worth studying and paying attention to them.
Perfect. Yeah, thank you very much.
Thanks.
It is something we have to take into consideration, I guess, especially the colleagues and the teaching the music teachers. Yeah, good. I think we are past the hour already. So I always say, in the end, discussions are very animated, and we can have very cheerful and we can go on talking forever, but we need to keep the timing. So we'll ask everybody to give a hand of applause to my team for the talk. Open your mics and thank you.
Thank you very much for the invitation and for the exchange. That was really nice.
Nice to see there's good stuff being done just south of the border, right? We should aim at more exchange between us. I know you have a good collaboration with Biscainho in UFRJ, but there's more around here. If we are able to exchange more, that would be great. Okay, guys, thank you very much for your audience. Thank you, Martin, for your time, and see each other next week. Bye-bye.
Bye-bye.
Thank you.
Thank
Ciao,
you.
ciao.
Thank you. Bye.
Bye.
Martin.